Very small. You'll get, guys, so you have to know two-phase can be asked, dual can be asked, most likely both. Most likely both, because we have to give you some more for the goal programming, but either or will, if we don't one of them, we'll ask both. Okay, so be prepared for two-phase to get some marks there if they ask it. It's like your bonus. Okay. I'm gonna do that. Yeah. I was thinking, I thought so. Okay, so I'm just quickly opening my slides, and then for the online students, let me share my screen. Let me just. Okay, online students, are you good with seeing the screen? Is that working on your side? Awesome. Okay, cool. Online is very active, so that's why I'm going to be very split between you. Okay, so for dual simplex, you already know the basics, so I'm going to go to Korean Auto. But maybe just for in-class purposes, guys, if I quickly look at the Farmer Brown one, I have to now set my settings for my pen. Just give me a second. Yuyen. Let me just set my setting area. Let me just make it the right area. Let me see. Yes, okay, we're good to go. Okay. So remember, I'm online, so don't talk too loud, otherwise it's going to be very distracting. Okay, so first off, just to recap quickly, what do you do with your Z values with any simplex? You take it over. So it becomes minuses in this case, but either or its signs changes, right? This is a greater than sign, so for two-phase you'll have your A as well as your XS. But what about dual? You have your E. So you start with subtracting, but you have to make the E basic before you can start with dual simplex, meaning? Yes, but what you do for the one, you do for the whole constraint. Okay, but what do I do with these?
You just add a slack.
Just add a slack. There's no, it's already in the feasible area for less than, hey? So it's only the problem is when it's greater than. But now for recap purposes, what do I do if there's an equal sign? I like that, yes?
Make two constraints. So you take the constraint with the equal sign and you make two of them, and then you make both those signs, and then you just repeat the steps.
Repeat the steps, exactly. Online is typing. Let's see what they say, because I told them yesterday. They better know. Okay, equals. We split it into one with less than and one with greater than. You duplicate the constraint, right? So whatever constraint it was, let's say your constraint was something like constraint 4, x1 plus 3x2 equals to 5. I literally duplicate the constraint twice. So the constraint for the top one, we normally say like 4 part 1 to say this is the part for the less than side. So we go, okay, plus 3x2. That one's going to be now less than or equals to 5. Our 4 part 2 is going to be exactly the same, but greater than or equals to. Now we have to convert to slack and excess. So the less than just gets slack, then that changes to equals. The greater than, you subtract your E, changes to equals, but then I have to multiply by -1. And then I put it in my table to solve. If that constraint really existed, guys, let me just write this one out fully. So that's then positive E, 4, because it's constraint 4, becomes equals to -5. Between this constraint and the already existing that would have become -3, which one would I pick? Which one would I pick to pivot on? -3 or -5? -5. -5, the biggest negative. Okay. Very good online, you're all good. So remember, if you've got an equals to constraint for dual simplex, split it into two constraints. One becomes less than and one becomes greater than. Why? Because it's still going to force it to be equals. Does that make sense? I mean, it's like saying x1 greater than 2, greater than or equals to 2, x1 less than or equals to 2. You can't have both above and below, so it's going to make it equals. But we don't have artificial variables in dual simplex, so we have to go this route. Okay, what did you have to do with two-phase? What did you have to do with equals? How did you deal with equals in two-phase?
This one should just leave it or not?
Let me see online. Christo is eating a brick there. Gideon. Yeah, so you'll see there the E that I added there for the second constraint, right? That's it. It's not above, it's you add a variable. And then in your W, it will be included when you calculate your W, because it has an A. Okay, so make those notes. You need to be, okay. Is it a bit laggy there? Let me send a quick message to our person. Online students, am I back? I did send a message so long. Let me see. Making jokes. Okay, are we okay online? If I go like with my mouse around, you know, is it okay-ish? Okay. Right, we're good to go again. Let's go. So please make your notes quickly for two-phase. If you see an equals, just add A. If it's dual simplex, it's a whole other process. Copy the constraint twice. One will be for less than, one will be for greater than, and you repeat your steps of slack and excess. That's it. Okay, let's do Korean auto. The beautiful. Maybe I should just discuss this very quickly, just to recap. Guys, dual works very similar to two-phase. It starts in an area that is not feasible, and then it moves to an area that is feasible, if there is. Okay, so if you look at table initial, x1 is non-basic, meaning it is equals to, who can tell me? Yes. x2 is equals to? 0. So right now, this is where it is. Is that the feasible area? No. You start at 0, 0 always with a simplex, but that's not feasible, meaning you had to do either two-phase or dual simplex to get it to a feasible area first. So phase 1 is getting to a feasible area. So now we go table 2, we pivot, beautiful. What is x1 now? Yes, and x2?
3.
Online, what's x2? You're quiet. I have to make sure you're still with me. Okay, someone's typing. We've got good news there. Thank you, Chrisu. 3. Right, so x2 is basic. It is equals to 3. Now, where's that on the graph? Do you see it's in the feasible area? Meaning I'm going now to do which phase? Phase 2, which is? Primal simplex. All right. So meaning now I'm looking for the optimal. So we pivot, beautiful. What is x1 now?
X1 is
2.8.
2.8.
There we go. Everyone was like 2 points. There we go. You guys must type faster. But at least Chris 2 is trying. Yeah, you beat them now. Yeah, okay, sorry, someone beat you with the answer. Finally. Okay, but where are we now? We are at the 2.8 and the 3 for x1 and x2. So it meant it moved from that position to that one. Why did it stop? Yes. On 9, why did it stop? Come on, let's see if you guys can type fast. There we go. Table is optimal. Well done. Ewald.
Sorry, ma'am. Why did we use X2?
So x2 for the first table.
Yeah.
So here, remember, you start with your negative, then you check inside for any negatives, then you do your ratio test here at the bottom. There was only one negative, but that's why this was chosen.
So, okay, the ratio test moved on the bottom.
To the bottom. See dual as you're doing a transpose version. So the difference between dual simplex and two-phase you're pivoting on the values on top, right? So the values that you're actually pivoting are the coefficients of the constraints. So you're working with that. Whereas dual, you're working with the right-hand side values of the constraint. So it's like a different perspective. You're working from it from a different. One might take longer because the coefficients might be lower for the x values, then it might take faster or longer, whereas the other way around, it could have been faster that way because the values could have been larger on the right-hand sides. So it's very hard to know which one will be better at the moment. Both of them will work. Okay. All right. Yeah, you guys can't lose again. Right. Let's see. So that's it. Let's go to Korean auto. Equal sign. There's supposed to be an equal sign. Take it over. It becomes, and then another equals to. Okay. Now for the online group, what do I do with my first constraint? Like, is that going to be positive 7 or negative 7? What's going to happen there? Thank you. Negative 7, right? Negative 7x1. First, it would be okay. Actually, subtract our E1 here, and then okay, so that's why it becomes negative. That will then be negative. The E will become? Yes. Why is someone, oh, Dean, what test on Monday, what? Test is tomorrow?
Yeah.
Did someone say Monday? I said tomorrow.
No, not actually. I'm going to study.
Yeah, exactly. I said be prepared for Monday in terms of graphical solving, hey? Why? Because you're doing graphical sensitivity analysis. That's your start. So you had to be prepared for Monday's class. And I'm not here for the online students. So online students, let me quickly just talk to my online students. No, I'm literally not here. So I'm gone on Monday. I'm sorry. Online students, the arrangement was that you guys can work on your assignments and stuff. I'll catch you up on Tuesday. I might be here as well on Tuesday. We'll see. Right, but for online students, I'll see you and catch you up on Tuesday. All right. But Monday, on your assignments, you know that it means we're going to have to work a bit faster, but we'll be fine. Quickly make your table, guys. Just giving online guys to talk to me, you know. So note Hypeflex is breaking today. Let me refresh Hypeflex quickly. Again, I just did a reshare for the online students just to make sure that we can. There we go. I'm just closing all other tabs quickly. Let me see. Okay, online, let me see. I'm going to write something. You tell me if it's okay or not. So let me just quickly do that. Minus E2 times that by minus 1. Is it okay? A lot smoother. All right. Okay, we're back to action, guys, in class. All right. What does it mean when you have more of excess E again for two-phase? Well, two-phase or dual simplex, if you've got E, that means excess. So if excess is a certain amount, that amount is the amount that you're using more than your right-hand side value. So if E is equals to something, it's telling you how much you're using more of what your right-hand side value was. If it's S, how much you're using less than what your right-hand side value was. I hope I answered the question. But for online, there will be no lecture as far as I know, but an announcement will be made if there's going to be one on Monday. Right, so if there's no announcement, then I'll see you on Tuesday. Okay, or they might announce you on Tuesday, but either or. Check for an announcement if someone's going to take you. Right, then you know. In class, you're here on Monday. I didn't talk to you now. Okay, you're here on Monday, unless if an announcement or something is made. All right. So be here on Monday, please. Okay, let's see. Let's make it on Excel. Let's not waste too much time. Table initial, hey? What? Oh, on my screen it's gray. Weird. Okay, let's see. Minus 100. Oh, it's minus 50 first, right? Yeah. Okay, so you know what to pivot on already, right? You've got two negatives. You are doing dual simplex, so you're trying to get rid of negatives on the right-hand side. Never the Z, guys. The Z is not something you move around on the graphical solution. You're moving on constraints. So don't try and pivot on the Z there. That doesn't make sense. So you've got these two negatives that you can work with. Largest negative. I know some of you know already the saying, but for those of you who don't know, we're talking about you first check which ones are negative, Then ignore the sign, the largest one, because it will make the largest difference. Okay, so ignoring the signs between 28 and 24. The 28, you got that? Yes, online is keeping up. Okay, now, something that you have to know, when you do dual simplex, when you choose that negative, you can only pivot on negatives throughout. So when I choose now from there the column, I can only pick between -7 and -2. Those are the only choices I have. But we have to do that whole positive ratio test thing. So we change it to absolute. I think in class you already did this. You use the absolute function to change your ratio test values to positives because we assume everything's going to be positive due to those negatives that you're choosing. You're not using any other signs. So we're going to assume that they're going to be positives. You don't have to, but it's going to confuse you if something's positive and minus. So rather use it to just see everything as positives. Because then you know ratio test is always the smallest positive no matter what. Okay. So Z divided by pivot row. And that you can drag for everything that is negative, right? What now? What? So you can drag it and then just go delete the stuff you won't be using, right? Because you won't be using those stuff. So you can drag it until and then delete the rest. Okay. Because it's the same formula being applied for everything. All right. It's just gold that's a painful one, but same formula for this one. Which one do I pick? Smallest positive, right. For dual, there will not be anything other than positive because we're making everything positive. So if you find a 0 in dual, you see it as a positive. Do you hear? You're using absolute to make everything positive. So even a 0 is positive. Okay. I know it's weird. So even in dual simplex, even a 0 is positive. Okay. Okay, smallest positive is x1. Let's pivot. The online students, you guys probably already have the answer for the next table. Do we need to continue pivoting after that next table? And here a yes, someone's saying no. Ooh, okay, now we have to go check, hey. Remember to check phase 2, hey? Don't forget to check phase 2. 50-50 shot there, hey? What's the formula? Who remembers? For in class, what am I doing? The primal simplex formula, exactly. So just to recap, to tell you what am I doing? So it's equals to the position, same position, previous table, minus open bracket, pivot column. But it needs to stay in the row that I'm calculating, just in the previous table. So I'm in Z row, meaning in my Z row, I look for the pivot column, column 1, well, X1. F4 how many times? 3. You remember the 3, 2, 1 thing? Okay, then I multiply with the pivot row. I stay in the column that I'm calculating. That's the column, right, that I'm calculating. I stay there, but I go to the pivot row in the new table. Do you see why I click that one? New table. F4 2 times. Something not there yet. Okay. So you drag that down. Yay. And you drag that. Right. Oh, Milenka, I was hoping you were going to get the right answer. Try it now. Tell me, get it. Please get it. Are we done though for the class students in class?
Yeah.
No, why not? What do you see? Negative. Online, what do you see? You probably didn't hear them. Negative on the right hand side. So we have to continue, right? Negative 16. Which ones can I pivot on or choose from?
X2 and E1.
Thank you, X2. Oh, you guys online is quite fast typing, hey. X2 and E1. But we have to do our absolute check. Okay, so we do equals absolute Z divided by pivot row. I just have to slide it in there, but Z divided by pivot row. Okay. I can drag that for everything and then just delete the stuff that are not negative, right? Because it's only applied to negatives. Which one do I pick? Now online, let's see you. Yes? Okay, online, what do you pick? Yes, okay. So we're going to go with this one. Although, Petrus, you did beat the in-class students because you did say before we asked. So they're trying to beat you at all costs here online. Okay, so this is table 3. Let's do our pivoting. So equals position minus open bracket. I stay in the row that I'm calculating, which is Z, right? But pivot, column, F4, 3 times. Multiply. I go to the column that I'm calculating, but I move to the pivot row in the new table. Do you see why I'm clicking that one? Pivot row was constraint 2 in my new table. F4, 2 times. Okay, so I've been talking to the online class and been telling them over and over 100 times. In class, you should be clicking and not thinking. Okay, this step should be just clicking and typing. Not thinking, oh, but what was it? No. No. Okay, so tonight you should be clicking until it's just clicking. Okay. Drag and throw for your whole table. Okay, you've got a bit of a latency disadvantage. Okay, don't break it, Evolt. Okay. Pivot value, change it to that value divided by itself, lot, once. Drag left and right. Left and right. Okay, let's see who can answer first. Are we done? Are you sure? Thank you, Joshua. So I wanted a bit more, right? We say yes, but are we really, Like, why are you saying yes?
X1 and X2 is basic. And also,
Don't take that. But if your negative right side value is being positive now, that phase 1 is complete. Okay? But it means you're moving to phase 2. So you have to go check what kind of problem was this. Min, why do we pivot in the Z row? Because it's positive. Do we have any? Oh. So it's already optimal. It's only in dual simplex that you see it, the phase 1. Okay. So it's optimal. You can make your little star saying I'm a star. There we go, optimal students. Okay, now, what is x1? Who can tell me what is x1 is equal to? Online students, you give me x2. The class students are too fast. Give me x2, 1.4, good. What's the z value? Okay, now what is E1?
0.
It's equals to 0. But you can tell me what does it mean? There's no excess. It's above by nothing. So if I go back to my constraint, if I'm looking at high income women, which is the first constraint, how much am I using? Everything. Do you get that? No excess, but I'm using everything. I'm using the 28, There's just nothing above the 28. Excess is 0. Got that? So I'm using literally 28 out of 28. Okay. Same with E2. Yes, 100%. Same with E2. It's equals to 0 because it's non-basic, right? Non-basic, it means it's equals to 0, nothing above. So make notes for yourself saying, oh, E1 equals 0, so it's not above, right? E2 equals 0, so it's not above. It helps you with the goals as well, actually. Okay. They have it at its absolute best solution. Yes, that's very true. Hey, thank you for that, Chris, too. Because there's nothing more that they can use, so it's the best. Any questions for dual simplex? Are you okay now? Okay. You have to practice though. It's not something that's gonna come to you and you're gonna be done, right? You have to practice this. So even delete the sheet and redo it. Okay. Guys in class, I haven't obviously told you, go back to Solver, first year work. Solver will help you know whether your answer is correct. Why? Because with Solver you pick simplex. This is simplex. Go back. Do yourself a big favor. Remember, if I ask you two-phase as well as dual simplex, and you got it wrong twice, rather use Solver quickly, just to make sure which one is incorrect. Okay. Guys, Solver, go do yourself a favor. Go back to Solver. Okay.
Guys, I'm giving out classes for 5 random calls. I told you about 2 weeks ago.
I don't think we have one of an EJC, so I don't have one, unless there's one in the slides. I don't think we had one. So making up something is a bit hard because I won't know if it's going to work out or not. So that's a bit tricky to do. So it's going to be exactly the same. You're just going to have, let's say this constraint was equals, you'll have a slack as well as an excess. It's going to be exactly the same way. Let me just go back there. E1 equals 0. Where's that coming from? It's non-basic variable, which means it's equals to 0. Non-basic variable, which means it's equals to 0. This is a basic variable telling you what it is equals to. Basic variable telling you what it is equals to. Right, so non-basic, it's equals to 0. It's XEAS, is that the correct way? XEAS, what do you mean, Petrus? Do you mean like the order of your variables? Is that what you mean for two-phase? I think that's for two-phase, I'm assuming. The A for the table order, yes. It honestly doesn't matter. So what's going to happen is you always pick the smaller subscript. So even if you moved your stuff around, you'll have the same smaller subscript as me. But guys, this applies to even you guys in class. So it's just asking if the variable positioning matters. Like if I say A instead of E first, does that matter? Technically, no. Your subscript matches you with your constraint, but that matters. So in a test, if I say constraint 1, 2, 3, follow that order, you have to follow that order. Because otherwise your labels will be different, everything else will be different, and you'll be thinking it's 100%, but it's going to be different order in your answers. So if I give you an order of, let's say I tell you, what is constraint 1? What is constraint 2? I'm hinting towards, that's the first one, that's the second one. So use the same order. Then in your table, whether you put E first or A first, it doesn't matter, but the subscripts will tell you which one to pick. Okay, that's how you would know if you had a ratio tie, where they're the same thing. You would use the one with the smaller subscript. So it doesn't matter which one is first, but the subscript will help you pick. Okay, so online, that's good. So just to go back there, just to, for, I think, JC, you asked, so just take a photo of this so that you can maybe add this constraint extra. and then you can see that you're going to put it in as two separate ones. So maybe let me just finish this writing. So that's part, let me just do this for you. So for part 1, let me just write it out for you quickly. So when you put it in a table, it's going to be x1 plus 3x2 plus s4 equals to 5. For part 2, it's going to be negative x1, negative 3x2 plus e4 equals to minus 5. And then you're going to just do exactly like we did just now. So that's the only difference, is you're going to have two parts. Guys in class, shh. I see someone asking about unrestricted signs. Maybe not so much in your test, but you saw it in your assignment already, I'm assuming. Unrestricted signs. It's there. One of the LPR about the signs like what we saw. I sent a message, but it's fast. Not to you, but yeah. He's been off for shame. Give him some. When you see him next week, be like, I hope you're okay. Please be okay. I don't know. No shade, but we don't want to get sick. No. Guys, so just a note, so the online students already know this URS stuff in the assignments, and they already know that you can open and close and open and close. So the guys in class, you can open and close and open and close. Just not submit until you are done. Okay, I mean, if you submit, you submit. You're saying you're done. Right, so you can open and close that assignment as many times as you want, but when you're done, submit it. You have to submit it. Okay, I don't think it's going to automatically submit for you. So you have to go and actually finalize and submit. Okay, URS is definitely there because they are asking you URS. It's unrestricted. It just means you can have positive or negatives. It's first year topic. So go to your slides. Hint. Go to your first year slides. It will help you a lot. Okay, that's all I'm going to say. Use it. Right, let's see.
How many marks can a goal setting be? How many marks can goal setting be?
It depends. We usually try to level it out or balance it out with other questions, because imagine you throw all eggs in goal programming, that's a bit much. So we balance it out based on how much other questions count, and we make it very similar to that, but obviously depending on how much we asked. But it will be not like your biggest part, if that makes sense.
So
like
you leave it out and you can do everything else.
You can maybe, but I didn't see the test yet, so I can't 100% say. Okay. But usually it used to be so that you can still pass even, but don't.
That's not
Don't skip it. Don't skip it. All right. Okay, so online students, I'm going to repeat some stuff right now with some extra stuff to help the students in class with something they asked. But just bear with us. Let me just maybe say from current slide. Yes. Yes. Yes.
There is a difference between preemptive and non-preemptive, right? Okay, so you can do like what you said then, right?
So non-preemptive, you're saying penalties.
Yeah. The one you said or higher.
Your order of importance. Yes, 100%. Okay, so I'm not going to redo this one completely because I mean that would be wasting some time, but I'm going to go through where does that Z value come from, that canonical form come from, just so that you can see where it comes from, so that you have a way of checking. If you don't get it, skip it. I mean, just study the Z then. Okay, but I'm going to say if you see this, do this, if you see this, blah, blah. But first things first, you should have picked up that for this goal, there was a penalty of 200,000, which means that's something I want to minimize, right? But technically, you are minimizing the deviation from meeting that goal, not really the penalty. You're minimizing the deviation from that goal because when you don't meet it, you are paying a penalty. You get that? Okay. I'm saying this because when we get to the one of order of importance, you're minimizing the deviations. Okay. So let's see. I've got a penalty of 200. I'm going to just divide it by 1,000. But at the end, remember to multiply it by 1,000 again when you get your final answer. Okay. Now, 200 for what? What are you being penalized for?
Loss of sales.
Loss of sales. Falling? Does that make sense? So, G minus. Okay. Now I'm going to talk about it the other way around as well without looking at the penalty. So we want it to be for that constraint at least greater than or equal to, right? So what do I minimize then? I want it to be above, but what do I want to minimize happening? What deviation should I minimize? Think about deviation, something that I don't want. Going under. Gideon was typing there. Gideon, is that what you wanted to say? Want to see? So you want to minimize going under. There's probably a song like that, hey? Shortcoming. You want to minimize the shortcoming, right? So you are minimizing the G minus. Do you get that? So even if I didn't have a penalty, I think of what should not happen. Reason being, you might not meet the goal. But the closer the goal is to equals, the more likely I have resources for other goals. Do you hear that? Because it's not likely that you'll meet all your goals. I mean, really, even in life, will you meet all your goals? We're hoping, but I mean, it's a want. Okay, so the goals are set up in a way that you can deviate, but if you do, we try to minimize. Deviate means going the opposite direction. I'm going in the wrong direction. Okay, so I minimize what I don't want to happen. So if it does, we try to still meet other goals at least. Okay, so with that being said, what will happen with the second goal? G what? Plus or minus? Minus. Right. Even though it's goal 2, you'll say G2, the whole usual stuff. That's G1. This one is going to be? Minus. Because it's all of them are at least. Okay. So don't go and say at least, oh, okay, that means plus. You're trying to minimize the deviation, meaning if it doesn't go above, I try to minimize whatever happens below. So think of it as opposite. All right. So if you've got a greater than sign, you're going to minimize under. If you've got a less than sign, over. If you've got equals, both. I mean, if you want something to be equals, you don't want it to go up or down. It's gonna probably go. You can't say no. But when it does, you try to minimize that. So you're gonna have an up as well as a down if it's equals. Sad territory. Okay, so now just to show you where does that calculation kind of come in. But what you need to know is on Excel, we use the elimination method. On paper, I'm going to show you a substitution so you see it gets you the same result, but you don't want to do that on Excel, okay? So I'm going to just show you why those values turn out to be the values that you got on Excel, right? Because that whole calculation might be like, why are we doing this, right? So right now we are saying, let's just look at Z1. So Z1 is equals to 200 G1 minus, right? You're minimizing the amount below because you want it to be above, okay? But that has to be also in terms of your constraint, because what tells you whether you're meeting this goal? Your constraint for that goal. The one with the 7 and the 3, I think it was 7, 3, yes. Or for goal 2, that was low income people, because the goal is to do with low income people. So I have to look at those values then specifically, because I have to convert my constraint in terms of the penalties to be able to figure out how much penalties I'm going to pay. Because all in all, x1 is the amount of something, right? x2 is the amount of something. So even if I don't meet something, I'm still going to have x1 and x2 values that I can use to see what's happening with my goal. But those values need to be in terms of the penalty to make life easier for you. All right. I'll show you now on the table what would happen if you didn't do it. It's a bit painful. Okay. But going back here, so let me just go to the previous one. So the constraint for goal 1, so I'm just going to write there the constraint for goal 1, if you started, would have been 7x1 plus 3x2. You'll have your plus g1 minus, right? And minus g1 plus. Why plus g1 minus? Because when it's under, you have to add to make it equals. Did you hear what I said? When it's under, I have to add to make it equals. If it's over, I need to subtract to make it equals. That's where the signs are coming from. Okay. So if I want to make this equals, let's say I substituted some random values and I got my answers, and eventually I got with an answer of, I don't know, 50 equals 40. Is 50 equals to 40? No. But am I over or under? The right hand side is the check, right? But we are over. By how much? What should I do with this 10 to make it equals? Well, you can just minus, right? But this is the over amount, right? So I just have to subtract that to make it equals. If I was below, then I had to take that amount that I'm below and I have to add it. So that's why the 1 is minus, 1 is plus. So the reason why I'm showing you this is when you set up your decision variables, that tells you what is over and what is under. Plus doesn't have to be over, it's just us logically thinking plus is exceeding. But someone could have swapped this stuff in a different sense. So let me put it in perspective. So here we're saying G plus means amount by which goal is exceeded. So it could also be amount still needed to meet the goal. Do you see how that's now the opposite? Do you see how that's now the opposite? If we talk about the amount still needed, am I over? I'm under. Do you get that? So it all depends on how did you set up these variables. Because now, if that's the amount still needed, my G plus is for under. Will those signs still be exactly the same? They will be opposite signs. So where my plus G1 minus would have been plus, it would be minus G1 minus. Because it depends on what are you looking at. Are you looking at it being the over or the under? Hopefully no one will punish you and it will be plus for exceeded. But you have to check. If they're saying that is the amount that's still needed, it's referring to short. It's referring G1 plus to short. If something is short, like 30 out of 40, will I be subtracting? I will be adding. But now we used to say short. No, short is not plus. You get what I'm saying?
It makes more sense though.
It does. So someone might put it this way, and you have to know it means exactly the same thing. So you're adding the amount that's actually still needed. just the opposite way around. That's why decision variables are extremely important. You can't do anything without knowing what they are. Okay. But if they say it's just exceeded, then it's the amount that's over, and you subtract that amount. Right, so make a note for yourself. If this is opposite, all the signs will be different. Because now I'm saying plus plus instead of minus plus. You got that? Instead of plus and minus, it's going to be minus minus. So the signs in front will just be the opposite because I'm just doing the opposite. That's literally all it means. But it's going to take some keeping track of, because you have to then continuously tell yourself in your head, plus does not mean exceed. Plus means short. You got that? Plus means what I need. So I'm short. So be careful, read your decision variables, don't just jump in. Okay, please, that's going to mess you up as someone that haven't seen it. If then you have to be prepared that it depends on the variable. Okay, so plus minus plus. Ooh, is it exceeding or plus? Yes, then this. No? Take everything else to the other side. So G1 minus, I'm making the subject. I'm taking everything else to the other side except 40 because it was on the other side. I mean, it is on the other side. But everything else I have to take over. Take over. Online, are you still okay? What happens to the G plus? Becomes positive G1 plus. You got that? Do you see this? Is not there. Hint, hint. Should not be there. You're replacing it. You're going to substitute it. Okay. Now we can substitute. Cat attack. We have cat attacks online. Luckily not watching your webcams today. So we're going to substitute that into here. So Z1, why did I go with red again? I don't know why I like red. Sorry for who doesn't like red. You have no choice. So Z1 equals to 200 times what? Substitute. What is G1 minus? 40 minus 7x1 minus 3x2 plus G1 plus. Now that 200 will be multiplied with everything. That's what the formula does on Excel. It multiplies the 200 with everything. That's it. Because now it's changing your x1 coefficient in terms of, yeah, it is 7 rugby per soap opera, but what is it in terms of the penalty? 7 times 200, because 200 is a penalty for that goal. So it's timesing every single thing with the correct penalty to say, what is it in terms of that x? What is it in terms of that g? But am I done though? No, because we always have to take everything to the left of the equal sign. Do you remember that? Take it to the left, take it to the left, Jamil. Oh, someone was literally saying sing it. You guys are a good combination here in class, it seems. I don't think I've ever shown it to any students. I just saw people going crazy and I'm like, okay, let me show you. All right, so when we multiply and take it over, it is Z1 minus, I think it was 14,000 or something. I'm not going to give the whole value, so I'm just going to say the next one is minus 7 times 200. because I'm not going to do that right now. But you see where those values came from? Okay. Then the next one is going to be what? Negative G1 plus there with a 200, don't forget 100. But on the right-hand side, it's still the right-hand side. You get that? Please don't take the constant to the left. The constant is still your right-hand side value that you leave there on the right-hand side. Okay. You can take a photo. Sorry for the mess, though, but you are more than welcome to take a photo. Then at least you know where those values come from. Okay. Jamil.
What's more is this? Is it going to be like any sort of theory?
No, not physically like is it minus if, and it's like I'm asking you interpreting in terms of like what is G1, what is, it's like part of your practical. Okay. Red color blindness. I hope your friend is not in class. Okay, guys, the only tricky one is if you were working with the opposite sign. So let me just erase everything there. Go, pcha. Okay, it looks beautiful. Okay, so all of these were greater than or equals to, right? So we were minimizing the amount that it was below. Right, that was what we were doing. But the tricky part comes in when you've got a less than or equals to, because it does the opposite. So what it does is it actually maximizes, but we can't maximize deviations. That's terrible. Why would you want to maximize the deviations, guys? So we change it to min. So whatever final answer you get, you times it by -1. So make a note, if your goal is less than or equals to, you have to times the whole final result for your first table by -1 so that you can minimize, so you can still minimize. So every time you see less than or equals to. If it was equals to for the goal, you'll have a Z part 1 and a Z part 2. You can say Z minus and Z plus to indicate which one is which. Minus would be the one that's below, and the positive will be the amount that's above. But you copy the same thing just with the correct penalty. But will it be using different constraints? No, it's the same goal. Do you get that? When I set up the constraint something like 2x1 plus 3x2 equals to 40, I'm saying that I want it to be equals to, but it's probably going to go either above or below. So I want to minimize below or above. If both are met, then the goal is met, because then it's equals. If you're not above, not below, then you're meeting it. Okay, so make that note. It's going to use the same constraint with that whole plus G, minus G, blah, 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 same constraint. But in the Z row, you're going to have two separate Z's. Make sure you've got the correct penalties for each, because above can cost you more than below. Use the correct penalty, and then you're all set. Same formula like we always do. But we're going to get to that formula again. So I'm not going to do it completely. I'm going to start off, and then we'll do the other one as an exercise, because otherwise my online students are going to be bored, very, very bored. So we'll do an exercise rather a bit later. But just want to show you something. Oh, that was you for a moment. Okay. This is what you start with, right? That's not the initial table, because that's just saying, what do I want to minimize? This is your initial table. Most people take that as the LP as well. Okay. If you were to write this as an LP, just to make it a bit clear, let me get my drawing pen there. Just remember, when you created your canonical form, you had to take your Z stuff to the left, right? To write it as an LP, you have to take it back to the right, or the other way around. So it will be Z1 equals minus 14,000 x1. Do you get where this comes from? minus 600 x2. Because I'm taking it back over to the other side. This one will be minus 200 g1 plus. But the right-hand side, will that sign change? You can tell me. Online, can you tell me, will that sign change?
Yeah. Oh, wait, no, it doesn't.
Thank you. It's already on the right-hand side. Remember, when you took it to the left, you were setting it equals to the right-hand side value, right? But it's already on the right-hand side, so please don't go and change that one. Okay, that's
So you
already
know,
what it's
oh,
equals
okay,
to.
it's not
I
less
mean,
than
if
or
you're
equals
doing
to
basic
only-
variables, you're setting it equals to the right-hand side. Because that's exactly what you're doing. Okay. So make that note for yourself to be like, okay, if they ask you the LP, just do the initial table and then copy that by taking it over if they want you to. That's it. But how do we get that table though? Okay. Let me just do something before I do that. So I'm going to scroll a bit up. You'll see here that I want this variable not to exist for that set. Why not? Look back at what I showed you manually. Oh, I removed it. Oops. When we use substitution, we made G1 minus a subject. Then we replaced G1 minus with whatever it was equals to. Was there any G1 minus? I even highlighted to you and saying, it's gone now, right? Because I'm using substitution, it's gone. So that must be what? 0. So I have to make it 0. But I cannot use G1 and G plus. That's minus and that's plus, it's not like terms. This and this, not like terms. Do you get what I'm saying? Elimination, you have to work with like terms. Can I use 0? No, because then everything's going to times with 0. And you're going to have just a bunch of zeros, right? So I have to use the 200 and the 1. But what I do for whatever I do here, I have to copy it to the rest of the constraint. Because otherwise I'm changing the constraint or goal in this case. Remember, it's like when you multiply something to an equation, a linear equation. You can't multiply to just one thing. You have to multiply to the whole equation, otherwise you're changing the equation. So how do I do that? Okay. First of all, I want it to become 0. So I either need to add or subtract to cancel it out. Will they cancel if I just say plus or minus right now? Plus or minus 1. No, I need to make the bottom the same. In terms of the number, I don't really care about the sign. We'll use the sign. So I'm not going to do exactly the same bit. Let me just show you. So you want to cancel from the top first and then minus, but I I've got brackets because I need to take bottom. Can you just say time? It was 200 times 7x1 plus 3x blah blah blah. You had to multiply it with everything. So that's why we lock that 200. You can use minus or positive, doesn't matter. You just have to then, instead of adding, subtract, or subtract instead of adding. But let's see though. Okay, so right now it's not becoming 0. Who can tell me why? Think about the numbers. Minus 200 plus minus 200. Minus 400, that's not going to work. So will adding work? you have to subtract this one, because then it will cancel. So just to make it very clear, what did I do? I times this by minus 200 by selecting that cell, right? Now it's minus 200, minus 200. Should I add or subtract? If I add, it's going to be minus 400. Do you get that? I have to subtract that. That's what we're doing with that formula. That's all we're doing. Okay. If you want to do it by hard coding in a sense, you just say minus 200 there for the top one, because it's still the same as locking, isn't it? Same as locking, it's minus 200.
So then is the goal to get it to 0?
Yes, the goal is to get that specific G1 minus that you put in first, that must become 0.
That's like both keys, something like that.
Yes, yes. So you're going to see now when we do this one, you're going to go to that position and you're going to make that one 0. Okay, so just to highlight to show you that that's going to be for this one. You're trying to make that one 0 by using those two. Using those two, trying to get that one 0. So that's what you're doing. But you're dragging it for the row only because everything in that row must multiply with the same thing. And if you add, you need to add everything. You can't add, subtract in the same row. Different rows, sure. But same row? No. What you doing? Okay. So in essence, that's what we're doing. We're trying to make it 0. The only tricky part, like I told you, if something's the opposite sign, you have to times by minus 1. So that's the only extra part. Here, all of them are greater than, no multiplying. If one of them was less than, you need to multiply by minus 1 as well. Okay. Now, do I have to do this whole formula for the following? Let me just go to, which one was that? Highlands, probably. So online students, you're supposed to answer me this time. Do I need to times that bottom by something? Why is my mouse freaking out? Well, I'll close it now. If I take these two, do I need to multiply? No. You can, because it's going to multiply by minus 1, and 1's not going to make a difference. So you can use the same formula, but you don't have to, because the bottom is already 1. The top is 1. The bottom is 1. So you can simply add or subtract. Okay, so you can simply add or subtract. Yes, so you either go on penalty or priority. There's no other types of goals that you're going to work with. Okay, I just need to sadly remove this and re-click because my Excel there was like, nope, not today. Yay, okay, it's working. Right, so just to show you, if you wanted to do the shortcut, so don't do anything, I'm just showing you currently, right? So if I take these two, I go to that position of the one I'm trying to make 0. It's the Z that you're changing, not the constraint. The constraint is set done. I'm trying to get the full Z values. Okay, so it's the Z that I'm calculating. So let me delete this. Do I need to multiply the bottom with anything? No, because the top is also 1. Okay, so it's simply top plus or minus the bottom. Do you think I'm going to add or subtract? Subtract. Hey. Minus 1 minus minus 1 gives you 0. But I mean, you can test it. If you didn't get 0, you're like, ooh, okay, maybe I should add. You get that. Okay, but now tell me, what did I say about less than goals? It's going to be a problem. Look there. Do you see why I'm saying it's a problem? If you're minimizing your goals, will I pivot on something? So please multiply by minus 1 if the goal is less than or equals 2. Because you have to make those positive. Otherwise, you won't be pivoting and you'll say, oh, I'm done. You're not done. Okay, so just to show you on this one quickly, should I add or subtract? Yes, add. It becomes 0. Do I need to multiply by -1? No, they're positive, I'm happy. But that one I had to multiply by 1, why? Because my x values became negative. I can't minimize on negatives. Do you hear that? You can only minimize on positives. That negative z I like because it helps me remember that it's technically the other way around. I'll show you what that means just now. So that covers that one. So let me just quickly highlight that one. So that came from that one. These two you added, you got this one. What about the last one? That's where it is. You see it. I'm going to use this one and this one. Okay, should I add or subtract? Subtract, you get that? Do I have to multiply anything? No, you can, you just don't have to. Right, so if you want to study that formula, go for it. Just make sure that you add when you're supposed to add and subtract when you're supposed to subtract. Why? Because it depends on the signs. Okay, so I go and I say, okay, this minus this, does it give me 0? Yes, but am I happy? No. So I want to minimize. So I need to multiply the whole constraint by -1. So like I said, make a note for yourself. If the goal is less than, multiply it by -1. So this goal would have been less than, this one would have been greater than, and this one would have been less than. So if you get a less than, multiply it by minus. Do you see the -1 there? Let me go like red. Do you see it? Because I had to multiply by -1. I'm going to show you now why it's useful. Okay, because you're probably sitting there like, why? First of all, I need to minimize, so I can't pivot if I don't do this. Okay, but secondly, why is this useful? So without penalties, it doesn't really help that much, but with penalties, it's brilliant. So I'm going to show you the one with penalties. Okay, this one doesn't have penalties. You see it's the same values, right? So I multiplied by 1. Penalty of 1. Any difference? No. But the other example had actual penalties. Penalty of 200 for goal 1. Do you see that? For goal 2, it was a penalty of 100. Goal 3 was a penalty of 50. So if my z and multiplied with, let me just delete that. Let me first tell you this before I say that. Always when you get your answer, don't you multiply things back that you changed? So if you divide it by 1,000, you multiply it back. So if I multiply by minus, shouldn't I take it back for the final answer? Yes. Okay, so showing you each step, I can take it back to see what is the value for that z at that moment. So I take my z, right hand side, and I times it with the actual one of the z. Sorry, I've deleted that one for some reason. Okay, so I times it by it to see, is the z currently positive or negative? Now why? If it's positive, you're paying a penalty. If it's negative, you're getting money for completing it early. You get what I'm saying? So if it's positive, you're actually paying a certain penalty. But if that value is going to be negative, I'm getting money back for completing the goal early. If it's 0, it's perfect. There's no money lost or gained. Right. So this helps me know the penalties without calculating it manually. How do I calculate manually? I have to check what's my x1 and what's my x2, substitute it into the goal, and then go see what is the goal amount that's above. Now it says, oh, it's 1,000 above. But what's the penalty for it being 1 above? 200,000, yes, I know. But 200. So I have to times that 200 by the amount that it's above. That's a lot of work. Here I can see it in the Z values themselves because I multiplied with the penalty. If it's positive, I'm actually paying that amount. If it's zero, I'm not doing anything. But if it's negative, I'm getting money back. Now my question to you, did any of your scenarios tell you that you're going to get money for meeting the goal? It's very unlikely that someone incentivizes or anything. So make those zero instead. Okay, so to show you, for example, I've got a different one here. All of these are on Moodle, right? So please use Moodle. But it was, let me see this one. So you'll see there's a negative there. Do you see it? Why am I not including it in my total penalty? Because the negatives are money getting back. No one said you're going to get money, so you're not including it in your penalty. If you were getting money, I would include it because then I'm subtracting the money that I'm getting from the money that I'm owing to say I'm owing less. You got that? But because there's nothing like that here, I'm assuming I'm not taking the negatives because I'm not getting money, so why even take it? But it does show me the penalty in terms of what am I owing. So I add the positives and I see how much I'm owing. And you want to minimize the penalty in the end. The smaller that penalty goes, the happier I get. Right? Especially because those are in thousands, isn't it? Like it was, I think, 200,000 and what. So the smaller that gets, the better. Okay. Do you see how it's a bit useful to have these? You don't have to go and calculate the penalties. They are here for you. You just have to take note that if you multiply it back with the Z, it's negative, doesn't affect anything because you're not getting money. But if it's positive, you owe, you pay. So you can add all the positives together to see how much do you owe. How much is the penalty at that table? Okay. It's very useful because then you go step by step. Oh, penalty getting worse. Oh no. Right? It kind of hints towards, oh, this can't meet all the goals. Okay. So what's going to happen in some of your scenarios, you'll maybe go goal 1 meeting it, goal 2 not meeting it. Now you pivot, 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 pivot. Finally, you get goal 1 met, but goal 2 not met. That happens, right? With penalties, it's easier then to see when to stop because you're going to try and continue and then eventually be like, my penalty is getting worse and worse and worse, so it's not going to work. So it's a way to see. So if they give you penalties, you're like, yay, but it is more difficult. So it's a pro and a con. Okay. But let's try the one without penalties because that's where we were going to do. Okay. So if you want to first start it up, you can, but I think we need a break first. Otherwise, I'm not going to make it like, shoo. And I'm for the in-classes, are you okay if I go ask for them to switch on the thingy? Guys online, I'll see you quarter past. Guys in class, see you quarter past. Bye-bye, 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 go, go, go. It's going to become noisy, so I'll mute. What thingy? Chris to the aircon. I'll see you guys soon. They struggle to ask now. Online, sorry, we are back. Just answer some questions here. Guys in class, shh. It's a bit too much. Online, can you still hear me though and see the screen? Is everything still there? See some saying study support groups. Oh, that's so sweet. Very nice though. Okay, let's see. Where was I? Okay. Let me just go. Okay, so we're going to go through this one. Just in terms of the starting point, then we're going to do an exercise. Otherwise, my online class is going to be bored out of their minds. Okay, but some of them probably going to be happy that I'm doing it again, but we won't talk about it. We will assume I did a good job. Okay, so just to start this off, to tell you where to get the initial table and what does it mean when you get those values, how will you go from there? So I'll do like the first pivot and then be like, okay, you can now work from there. Okay, so first things first, normal LP in terms of what is X1, what is X2. So you'll see there they talk about how many color TVs and VCRs. So it's the amount of color TVs and the amount of VCRs. Okay. Very new age, right? So goal one, I normally start with setting up the constraint with our G's and stuff first, just to see, is it going to be greater than, is it going to be less than, what is it going to be when I start? So I go and I say, okay, in terms of X1 and X2, purchasing, what is that? 300 purchasing X1, because that's color TVs, right? So the coefficient for X1 is 300, because that's purchasing. Okay. What's the coefficient for X2? VCRs, not VRs, that would be nice. 200. Guys online, what sign am I going to use? Because we're saying a maximum. And like you guys are showing me not to give it away. Online, what is it? Yes, we're saying a maximum, so we need to use less than that, right? Less than or equals to. The max is 20,000. If you want to divide by thousands, just make sure you divide throughout. So you'll be stuck with like 0.3 and 0.2, but I don't like decimals, so I'm not doing that. I'm leaving it. Okay, but if you divide throughout, at the end, multiply it back. Okay, so for goal one, when I create goal one, so Z1, I am making this my Z1. Who can tell me why am I making goal one Z1 and not Z3? Just random. First priority, right? So I'm making my Z1 because it's my first priority. They told us order of importance. The online guys are trying to keep up with us, but it's making some typos there. I'm waiting for a funny one. Right, but if there were penalties, how would we list our order? By penalties, by the coefficients. Which penalty would be more priority? Highest, largest, right? You go from largest penalty to smallest, because you want the larger penalties to be met before the lower penalties to minimize the amount you'll be spending on penalties. Okay, so make sure that you know that we're doing the Z1, Z2 in the order of what you're going to be solving. Okay, so the next one will be earning profits. What is the coefficient of X1's profit? Just giving them a chance. 150. Okay, in class, what is X2's coefficient? I agree. What's the sign? Yes, greater than you want at least, right? At least 11,000. That's going to be my Z2 because it's next important. Some people use P1 and P2 to say priority 1 and priority 2. You just don't use that variable ever again. It's just telling you which one is going to come first, which one's going to come second and third. It's to keep track. That's all. Okay. What about the third one's coefficients? X1. Online, you guys. X1's coefficient for the third one. Storage. 3. In class, coefficient of X2. 1. What's the sign? No more, right? Smaller than or equals to 200. That's specifically for Z. 3. So I'm going to put it in that order. If it was not in the right order, I shift them to the right order. Okay. All right. Now to the tricky part. Okay. Let's start with the Z's first. All right. Let's use purple. So let's start with Z1 equals. You're still minimizing all of them, hey? Minimizing deviations, right? So if I want the first goal to be less than, what am I minimizing? Yes, very good. Guys online, I hope you didn't hear the answer. What are we minimizing? How do you know if when it's a penalty of priority? So in this case, there's no penalties given. So it's something like you're going to pay this amount for every amount that it's under for the goal. Then you know it's a penalty. So just to go back, for example, to blah, 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 blah. I'm looking for that part. So they say there that each million exposes falling short a penalty of this. So it's literally for each X. So you have to multiply that penalty with the G to know if the G is below, then it's that amount. Then I multiply the amount of the penalty. So that's why we include the G then. But that's how I know it's a penalty, because we're talking about a penalty. If I don't talk about penalties at all, I have to have some order of importance. Otherwise, how am I going to know what to meet first? Because not all your goals will necessarily be met. So I have to think what is more important. It's very unlikely that we'll let you think on your own because me and you don't think the same. So we'll give you some guidance in what order to go, but if there's a penalty, that's what you want to rather minimize. But if I say skip the penalty and take this order, then you take the order. Okay, so read very carefully, what is it we want to do? So if we want you to minimize the penalties, look at the penalties. If we just want to give you an order of importance, even if there's penalties, if we give you saying these are the order of importance, you go for the order of importance then. You can use the penalties to check what's happening, but it's not going to be your focus. Okay. Or you don't have to, but I'm just saying you can. Okay, you can. Right, let's go to that one back. So blah 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 blah. There we go. We're finally there. Okay, so Petrus giving me a sharp there. Christy, you're saying G plus. So we are minimizing the amount for goal 1 that is above. Why? Because we want it to be below. So if it goes above, we minimize that. Because remember, your goals will not necessarily be met. So you're trying to minimize what it shouldn't do, because maybe it's going to. Think about what I just said and tell me about Z2. Will it be G2 minus or G2 plus? Minus. Online, do you say also minus? You've got a 50-50 chance here. I agree with minus. Why? The goal is supposed to be greater than. So I minimize the amount that it is not greater than, which is below. Okay. What about Z3? Plus, minus? Plus. Because it needs to be below, So I minimize the amount that it's above. Okay, take those over to the left. You're going to have Z1 minus G1 plus, Z2 minus G2 minus, Z2 minus G3 plus. Then we at least have our Z values that we can fill in. We're not done. We remember how to do all those calculations, but we have the start. What do our constraints look like without thinking too much? If your plus is exceeding, and it's minus plus. If it was the other way around, then it's plus plus. Okay. If my minus is short, it's plus that minus. Other way around, minus minus. Okay. But I'm going to go with if plus it's exceeding, minus it's short. So I do that, and then this becomes equals. All right. And I have to do that for every single constraint. So that would be G2, subtract the plus, and add the minus. It becomes equals. You're doing the same for every single constraint. Why did I write it again? I don't know. Don't ask. Okay, we're ready to put it into our first table. Okay, so let's get to our first table. Some of you are already probably typing away there, like. Yeah, that's literally what I hear. Just imagine the online students were not muted and they were all typing. Yeah, guys, don't take it as a challenge, please. I'm just joking. Hopefully we can only unmute one person at a time, but... So at G1 plus, do you see I'm putting minus 1? Because that's what I took over, right? Then for Z2, it was a minus at G2 minus. Z3, which I don't know why I wrote as Z2, but it's the idea that counts. It's a minus 1 at G3 plus. So those are what we start with. Constraints? Well, you're just typing in the coefficients, right? It's going to be 300, 200, the minus for the plus and the plus for the minus. I usually don't even say table initial because I'm not done. I usually only make the next table that I call table initial.
So now, on the system, you also table initial, you know it's going to be that one.
Yes, yes. Okay. Then, guys, even though you've learned this from first year already, if we number tables, some people can start a table initial as table 0. Most of us say it's table 1, but a lot of people say it's not really pivoted yet, so it's table 0. Check on assessment queue, what do they do? If they say table initial and then table 1, I'm assuming it started at 0. Do you get what I'm saying? Table initial, then table 1, and it's 0, 1. Name yours exactly the same. Okay. Okay, here's still a lot of typing. This time I don't need to multiply because the coefficients are all 1s, right? But we can do the multiplication. Doesn't hurt. Okay. It's just less making sense. top plus or minus, I don't know yet, so I'm just going to put a plus for now. Then the bottom needs to be multiplied with whatever the top is going to be, because I need to get to the top value so that it cancels. Okay, you lock it when you select that top one, or you can literally type the top value. Does that make sense? Okay, you can literally type it out. What's the top value? It's minus 1. Okay. Now, what was my problem with this one? Let me drag so that you can see it. What's the problem? Minuses. I'm not happy about that, right? I'm going to put my Z inside as well because it helps. It's very useful in goal programming. Why was it minuses? Just remember what your goals were. So I'm just quickly going to go back to the slide. The first one, when we set up it as a constraint, it was less than or equals to, right? Second goal, greater than or equals to. Third goal, less than or equals to. So please take note where I'm getting this. Got it. Those come from the original constraints, the original setting up. Okay. And I told you if you see less than or equals to, you should know it's going to be multiplied by minus 1. But I can see it with the values, hey. But I need to multiply it by the whole thing by minus 1. Whether you put the minus 1 in front or at the back, it really doesn't matter. Drag it left and right. What's wrong, Sean?
It's supposed to be only the excess one, so you transfer minus 1.
Say that again?
It's only supposed to be the first one, so it's supposed to transfer minus 1. It's not.
I get what you're saying. No, this is because we are trying to change something that's not minimizing to, it's actually maximized. So we're trying to change it to minimize. So you're timesing it by minus 1. Okay. Purely for the fact that, look, if I didn't multiply it, it's going to give me negatives and I can't minimize that. So I times it by minus 1 to be able to minimize that. Okay. So let's times it and then drag it throughout. But do you see the Z shows me that I actually multiply by minus 1? Because in the end, I have to remember that it's multiplied. Okay. Okay. That was purely just for goal 1. You see there, I'm replacing the top minus or add the bottom. It cancelled, so adding was perfectly fine. Okay. Next one, this one. Put some colors for yourself so you can see what you need to use. Okay, so I'm going to do the same long formula again, but you can shorten it. I mean, minus 1 plus 1 is going to cancel. You got that? But normally we would go top plus or minus the bottom. I'm going to use plus just for now because I'm too lazy to think. Not really, but next part, you put your brackets because you need to change the bottom into the top. Meaning you need to take the bottom and times it with the top. But lock it or type it out. Okay. But is this going to work? Tell me, did it work? No. I need to make it 0, so plus does not work for that one. I need to subtract instead of add. Okay. Now it's 0. But if I add, it's not going to be 0. That's a problem. Okay. Do I need to multiply by minus 1 without me showing you? Online, do I need to multiply by minus 1? Look at these. Lamarche is helping you here in class. It's like, come on, no. No, because it's going to give you positives, right? Nope, no multiplying. Positives. The next one, let's highlight. I'm going to make it orange. So the top one is the one I'm replacing, right? Go to that position, change it. Okay, so we know top plus or minus the bottom. I'm going to plus for now, and then later on maybe change it. Inside brackets, what am I doing? I'm trying to make the bottom the same as the top. So I take the bottom and I times it with whatever the top is. That's the formula. So I times it with whatever the top is. If the top was 200, then I'm timesing it with 200. Okay, because then they will cancel. But will it cancel though? Yay! So adding worked. Question again, should I multiply by minus 1? Yes, because if I drag, do you see some problems? It's only my x's that I worry about, but I see some problems there. So I need to take everything and times it by minus 1. So keep these. I'm going to put them here on the side because I'm going to make notes. Let me just maybe make this a bit smaller. That was a bit too much. Okay, so now we're getting to the whole what to check and what to do. Okay. So without me saying anything, is goal 1 met? Online, is goal 1 met? No problem. Here we go. So remember, when you start, everything's at 0. Yes, it's under by. Yes, so it's under. And it's supposed to be under. Because your constraint is less than or equal to, isn't it? Let me show you again. So we usually just use the constraints to check basic or non-basic variables, okay? Because sometimes the top stuff can throw us off. Highlight this for yourself. This is where you check basic or non-basic. Is this basic? This? Yes, if I only look at the constraints, you get that. Okay, please don't look up there. The Z's are for the penalties. Right. You can put your zeros, please, feel free. Right. Positive 1 is basic. What is G1 minus equals to? Which tells you it is? Yeah, well. G1 minus telling you it's under, right? Under by how much? Don't worry, Malinka, someone in here was... It's okay, it's okay. I just hope it's not illegal medication. I'm joking. I'm joking, you're welcome. But you check there. Remember, if they swap things, then you'll be thinking about it differently. I have to remember what is minus. G1 minus means the amount it is short. So if that is basic, it is short. By how much? Lamash. Yeah. Z2, this one. Yeah, sure. Sure. Let me know when you're sharp. Not illegal, just contagious. Oh, okay. Someone got a good response for you, Ewald. But that is funny.
Why is there a minus 1 G2 minus 1? Isn't it supposed to be positive? Or am I misunderstanding?
So look back here. So when we were at our second constraint, it was instead of less than, it was greater than. So you want to minimize the below because it's greater than. The below. And the others went to the above.
Yeah, I -1 instead.
That's where you went. So fix that one. Okay, so goal 1 is met. You got that? Why? Because it's supposed to be less than or equals to. So if it's below, I smile. Okay. So you make a note for yourself. G1 met by, or we can say below by. It was below by 20,000. It's below by the full amount because we haven't done anything yet. Okay, does that make sense? So we still need a lot to do, right? We still have a lot of work. Let me make that one smaller and that one bigger. Okay, so I'm gonna make goal 1 red for myself because I know that's priority. I need to work on that. Do I even need to look at the other goals? No, but I'll probably ask you in a test. Okay, so meaning at this table, what is happening with goal 2? Yes, goal 2 is under, not met. By how much for the online students? Met? It needs to be below, right? That's it.
I just wanted to ask, isn't it better just to have the signs and the equal because it's exactly the same answer?
What do you mean?
Because if it's 11,000 and you need 11,000 and it's like greater than or equal and equal to, so isn't it better equal to each other?
No, that's the amount that I'm still below. So at the moment I'm at 0.0, meaning I'm below by 11,000 before I actually equate that goal. So that's how I state it. But if you put it differently, it's still okay, but it just means that I still need like that amount to get there. Okay, so I'm very far away from anything right now, but I'm happy because goal 1 and 2, that can be far away. Does that make sense? They can be less. They can have 0, 0, that's fine. But goal 2? Okay, so now look. Because most people go on row 1 and choose a pivot. No. Which goal is my problem? Goal 2. I could have had more red ones, but my priority is goal 2. Because that's higher than anything else. I don't have others, but that's the point. But what do I look at? Look at what I'm highlighting. I'll make it red to be dramatic. Jawel. Hey, careful. Okay. So Chris, you were saying Z2, but which pivot column? For you guys in class, which pivot column? Why is it X1? It's because of that 150. Okay, don't look at the 300. Coincidentally, it's the same. I'm looking at the 150. So now I can highlight my pivot column. What color? Let's go with, where's my nice purple? It went. Now you used to have a nice purple, but apparently not anymore. Ratio test, you do exactly like you always do. Right hand side divided by pivot column. Drag it down. Guys online, I showed you this 100 times. Which one? Lowest subscript. Lowest subscript, which hopefully would be the top one. Okay, how do you see it? So I take this 66, I go to the first basic variable that I find. It will only match with one basic variable. What's the subscript of that basic variable? 1, right? G1, but 1. Evil's going very complicated there. The other one, what's the subscript of that one? So which one's the smaller subscript? The G1, which matches with the top. Okay, so that's our pivot row. Now, how do you do the next calculation for the next table? How you've always done it. Guys, you will still calculate Z1's row as well, because Z1 will be affected by the changes as well. So you're not going to start pivot doing the calculation on Z2. No, the whole table. Okay, so let's copy our headings. I'm going to do it once and then we're going to go to an exercise, but I'll show you how the thing completes so that you can at least make a note to say what should I get to. So put your signs somewhere so that we can see them. Okay, top left, like you always do, equals position, minus open bracket, pivot, column. F4 how many times? 3 times. So you're basically building any other simplex on primal simplex. That's why you're using the same formulas. Because it's still called simplex, right? Called simplex. Okay. What do I multiply with? Pivot row is constraint 1. In the new table, go to constraint 1, F4, 2 times. Ready? Drag it. Drag. Just gonna drag so long. I'll open the formula just now, but I just want to have everyone see the values to see if they're okay or not. Then I'll double click there again. That's a good question. Really? Which 1,000? Look upwards. There should be something here on top that's not matching up. Unless if it's your formula, but I doubt. You got it? Yeah. Awesome. Guys online, you okay? Yeah, I'm okay. Maybe not happy, but okay, I'm okay. All right, now I'm not going to complete the whole thing, but let's look at the final solution, then I go step by step, right? Otherwise, I'm going to be pivoting, blah, 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 blah. Okay, so know that we are right now, this was table initial and table 2. Okay, so I'm going to go to the solution. Let's see, where did I have that? This is Highlands. You'll see I copied the whole constraint to show you properly, because that's technically what you are checking. You're substituting x1 in and x2 in, but thank goodness we don't have to do that, right? So the signs are there. Okay, so that's initial, and this is table 2. That's where we pivoted. Oh, sorry, this one is initial. This one is table 2. Okay, let's see if it's met, what's not met, and we take it from there. Okay, so G1, look at the plus and the minus, look at the constraints. G1 minus equals to 0. Do you understand why I'm saying it's equals to 0? Non-basic, meaning it's equals to 0. So is it below?
It's
By 0, do you get that? Above, non-basic, so it's equals to 0. Is it above? Technically no, but by 0, right? So if it's below by 0 and above by 0, it's exactly met. Okay, so goal 1 is exactly met, meaning it's capped out on the dot, not more, not less, on the dot. Okay, what about goal 2? It's below. Do you pick up it's below? Below by? Is that a good thing? No, because goal 2 was supposed to be greater than. So goal 2 is still sad. Not met. Goal 3, now look carefully. Is goal 3 under or over by something? I'm happy I heard that. Goal 3 is below, but by 0. So is it below technically? No, it's exactly met. Okay, but where's my problem area? Goal 2. Do you see why I highlighted goal 2's values there? Now you look for the largest positive, which is this half. That becomes my pivot column. Do the ratio test. Why am I picking the 0? Positive. Sean.
So, for example, if G2 plus also had a value, will you then subtract the 2 and then check the transmit?
If G?
G2 minus is equal to 1,000. But if G2 plus is also equal to something.
Can't be both. Can't be both. So either both are going to be non-basic, or one of them will be basic, but not both. Something's not okay if that happens. Because logically thinking, it can't be above and below at the same time. Okay, but I like the question, but no. Lamarsh.
So we established that the ratio test with 0 is the smallest
Positive.
for the ratio test only. So what if with the pivot column and the ratio test will intersect is 0, will it then still be the pivot row, or will it change?
Wait, let me unhighlight this and then you tell me what. So right now it was this, right?
Yes.
Okay. And you did your ratio test?
Yes.
Okay.
So the ratio test is 0, and it intersects with the pivot column. If that value will intersects was 0, will it then will we pivot in the column?
No. So if that value there was 0, it will give you a divide by 0 error. So then you'll know. So it's a good question though. So guys, a lot of you might have not worked with fractions, and it would be like 0,00. And then if you have your cell too small, it will give you 0. And then you will ask me, but it's 0, so is it positive there, negative? Is it really 0?
Yeah.
So let me show you what I mean. Was it 0 that I typed? Because it's rounding. Be careful. How will I know it's actually 0? Okay, so I know it's actually 0 if it gives me a divide by 0 error, because you can't divide by 0, right? So if that doesn't happen, maybe that's not 0. You get my drift there, right? So it means, so it's not 0, it's actually 0 point something. I put it as general, you'll see it's 0.01. But your cells could have been too small and saying it's a 0, but make your cells bigger. Now you've learned something, right? Be careful. Be careful. So for NBV, it's 0. Safe to assume it's met. For that G, yes, so if it's G minus, then the minus part is met, but you can't say the whole goal is met. If it's non-basic for both, like we had here, then we can say safe to assume that goal is met. So if it's non-basic for both the G's for that G1, for example, G1 minus and G1 plus, both non-basic, it's safe to assume that goal is met. And exactly met, okay. Right, let's look on. So we pivot on that 0. We have to pivot on that 0 because it's the smallest positive. Okay, that corresponding column tells us that it's positive. You pivot, you do your whole thing, right? So we're now at table 3. So at table 3, goal 1, do you see it is above? By how much? By what is goal 1 above? 0. So is it above? No, still exactly met. Okay, met exactly. What about goal 2? It's below, because of the minus there, right? Below by 1,000. Is that okay? No, because goal 2 was supposed to be greater than. Have your signs, copy them down, right? Copy them so that you can see, okay, this is for goal 2. You can make notes, hey? You can say Z1 is supposed to be less than. Do you see what I'm doing? Z2 is supposed to be greater than. Z3 is supposed to be less than. Just to show me what am I looking for. Okay. What about goal 3? Exactly met. Okay, so now I'm focusing again on goal 2. It's making me very tired, but I'm going. Goal 2, we focus on never your right hand side, never, that's not a variable. So large is positive. Smaller subscript, do you hear what I'm saying? 50-50, x2 and g3, which one has a smaller subscript? x2. So that becomes my pivot column. I do my ratio test. Why am I not choosing the 0? It corresponds with a negative value. So don't. You're going to loop. Okay. Goes the smallest positive other than. Well, not really other because it's not positive, right? Do your pivot. We're now at table 4. Okay, in short, goal 1 is still not met. Can I say that? Okay, so goal 1. Why is goal 1 a problem for us if it's not met? Most important, order of importance, right? Okay, but let me maybe show you just the below and what. Check well, goal 1. Do you see goal 1 is now above by 2,000? Should it be above? Should be less than. So it's not met anymore. I'm not happy about that because goal 1 has higher priority. But I'm still going to try. You get what I'm saying? I'm still going to try and meet goal 1 now. But in my head, I'm thinking, ooh, that's not good. Why is it affecting goal 1 to meet goal 2? That's what I'm thinking. Can't meet all of them. But we have to check. So guys, sometimes what will happen is you'll pivot and it will all of a sudden choose something else to pivot on that might meet more goals. So don't go and say, oh, goal 1 is not met, I'm done. Are you sure? Could it maybe not be met still with other resources? So don't just stop. Okay, so I'm going to show you what to do and what to look out for. Okay, so look, focus. So at table 4, Goal 1 was a problem because it's above, but it's supposed to be below. Goal 2 exactly met, goal 3 exactly met, so I don't worry about them. But in order to meet goal 2, goal 1 went That's what we're doing now, okay. So I'm trying to sort out goal 1 now, saying, but is there maybe no way? There is none, but is there maybe no way? Okay, so I'm choosing the largest positive for which goal? Goal 1 now, right? So that's going to be positive 2. Quickly tell me what's going to happen if that changes to a basic variable? Because when you pivot on a column, it becomes a basic variable. So it will make goal 2 go over, which is nice. Yeah, but it's nice. You want goal 2 to be over, so go for it. Do you get what I'm saying? I'm not saying you have to look at it this way. It's just nice to look ahead and think, is this going to be pointless or what? Do your ratio test like you always do. You know that whole this divided by this. I have only, don't say it's 0, please. It's only 0 if that was divide by 0 error, right? If I make that general, you'll see it's actually something. Be careful for fractions. Use general and make sure your cells are big. Yeah, you can double click on the column. Okay, table 5. So don't do anything, just watch quickly so that you can get the idea of what's happening. Okay, so at table 5, you pivoted, you got your values. Goal 1 actually got met again. So let me just put these there. Goal 1 is above by, it's exactly met. So don't just go and say goal 1 is above R. No, it's above by 0. So it's actually not above. It's exactly met. So is goal 1 a problem? No, I'm happy with goal 1. Goal 2 went below again. So whenever I try to meet goal 1, goal 2 goes out of being met. But if I try to meet goal 2, goal 1 goes out of, is not met anymore. But how can I maybe see that it's not going to get better? So look at the amount that goal 2 is actually not being met by. So you'll see technically this amount, but you can look here. Goal 2 is under by 1,000. Goal 1 exactly met, that's fine. But if I now pivot again, I'm going to show you something. That looks familiar. Doesn't this look very familiar? I've done this before. It's a toxic relationship. Because I've pivoted on a 9,000 before. I've made G2 plus before. I'm going to loop. Because I cannot meet goal 1 and 2 at the same time. Luckily, in some cases, what will happen is your ratio tests will all become minuses. If that happens, you smile because there's nothing you can do. But in some cases, it's going to show you, but you can change G1 if you change G2. Now you change G2, then it's going to change G1. It's going to go like this because it's affecting each other, literally directly. So in that case, you're going to go quite on and you see, but oh, goal 2 is now met, but now goal 1 is this one. If I wanted to try and pivot other stuff, you'll see there's nothing even to pivot on. Look there. Like, there's nothing to pivot. Negative ratio test. Right. But you'll always try, just to see. But which one would then be the optimal table? Goal 1 was priority, right? Why am I saying table 3 and not table 2 or 1? Say that again, Sean?
in that table, goal 1 and 3 to make using those amounts of goals that we make.
Almost, but table 2 is also met. There's something else. Yes, it's other amounts that it's over and under by. This is the closest to meeting goal 2. Goal 2 is not met, but it's the closest to meeting goal 2. Because I tried to meet goal 2, didn't I? But then it didn't work. So that table before it didn't work is my optimal table because that's the closest I was to meeting goal 2. So I can go check the values to say, but goal 2 is under by 1,000. So if I maybe just go down by 1,000 for that goal's right hand side, I'm going to meet all 3. Do you get what I'm saying? So it tells me that if I get closer, that's going to be my closest. What can I now do to make it happen? Okay. Hopefully you'll never have more goals, but this is the idea. Then the last thing before we do a start of another one, I just want to go to special cases quickly. So I don't think everyone has done it. And I've been talking about special cases, but not really showing the special cases. Sorry. Sorry. It's revision. Yeah. Okay, so let's see if my online students remember a bit. So online students, with dual simplex, when do I know it's infeasible? With dual simplex, when do I know it is infeasible? Just want to know that they're actually there. Tell me you don't know if you don't know, but at least try. Amelia typing, let's see. I've got high hopes. Oh, Stephen, you try, but Yeah, well, I'm gonna throw you something. Close. Close. Look at this. What do you see? This is dual simplex. What do you see is weird? Look at the bottom table. What is weird? Dual simplex. There's no negatives to pivot on. Remember with dual simplex, you pick your negative and then you go inside that row and pick negatives. Are there any negatives in that row? When that happens in dual simplex, not goal. Goal is something else. Goal programming, you're just like, oh, I can't do anything, so I can't meet all the goals. But with dual simplex, guys, you're like, yeah, I'm gonna pivot. Can I? I have no negatives inside, making it infeasible. No solution. Do you see the graph there? Is there any feasible area? No, there's nothing. But there's no feasible area, so it can't actually get to something. Okay, there's no solution. But be sure it's not a you mistake. Okay, go try solver. The solver will tell you it did not find a solution. Do you get what I'm saying? And then solver tells you it found a solution and you're like, infeasible? Sure.
I put solver can solve like x6 because that's why I asked you to do that.
You can solve x6. Remember in solver in the constraints, you just pick greater than. It's going to give you solutions solution, so don't just click OK, hey?
You must read it.
You must read. Okay. So if it says does not converge, that means unbounded, infinite. If it says cannot find a feasible solution, then you know it's infeasible. If it says found a solution, you're like, yay, happy solution. You just don't know if there's alternatives or not. Okay. So the other special case, but before we get to the other special case, in two-phase, how do we know it's infeasible?
Because isn't that when you do the ratio test, they're all negative?
Mm-mm.
Oh wait, infeasible.
Infeasible.
That's unbounded.
That's unbounded.
Yeah.
What's infeasible for two-phase?
Isn't it when you got your final table and you can't put it anymore, you have a negative answer in your ratio test? Or
Close. In your what? Right-hand side for what?
for your constraint, for your
Almost.
Z function.
What do you have in two-phase that you don't have anywhere else? W. W, there we go. So guys, if you're doing two-phase and you get to a stage where you can't pivot anymore, remember phase one is a min problem for two-phase always, right? So you do positive, positive. Now there's nothing to pivot. Then you check the W row to say what is it equals to. If it's not equals to 0, infeasible.
Before you do the second phase.
Before you do the second phase.
Okay.
Because if it's infeasible, what are you going to do?
Nothing.
Okay, nothing. Okay.
Zero is infeasible.
Yes.
Okay.
But do a check. There are more things, like for example, I remember if your A's, I think if it was non-basic, I just have to, in the slides we say which one it was, then you can extra check to say, oh, okay, maybe I did something wrong.
If your A's were basic,
One of them was the, so it's also in the slides, just go double check that. It's like an extra check because maybe you did something wrong. Okay. Alternative solutions, guys, how do I pick that up? Look at what I see there. What did I highlight for you there?
the zero.
Zero where, specifically? In the zero. But what's the rest? Is it basic or non-basic? Non-basic. So if it's non-basic variable with a 0 and a z, I can pivot on that column and get an alternative solution. What is an alternative solution?
There are two or multiple solutions.
Two or multiple solutions. So graphically, it would have looked like you take your ISO line, you move it to the max point. Oh, it goes through multiple places. If it only goes through one place, it's unique. Right. But how do I see it in simplex? So you have to have an optimal solution first, hey? I mean, I can't say I've got more solutions if I don't even have a solution. You get that? It needs to be the optimal table. Non-basic, 0, specifically in which row? Z. Remember, two-phase, you'll have a W. Am I looking at W? No, 0 in the Z. Remember, in two-phase, you delete the W eventually. So we're not even looking at it. When I pivot on that X2, now how can I see that it's alternative? What is the Z value currently? What is X1? Guys online, what is X2 currently? Because they're too quiet. It's dead there. They went to bed. Okay, at least Christy will always answer there. We dead. Please don't die on me now. We have just a few more minutes. Come on. What is X2? Come on. But in class, you are correct. Yes. Thank you, Christy. So it's equals to 0 there, right? If I pivot on that X2 ratio test like we always do, what's it? Still 120. Do you see that? But the variables are different. So alternative means the Z is exactly the same. Same profit, same cost, whatever you were calculating. But the variables are different, giving you other alternatives. That's what it means. Yo, I'm dead. Then Joshua, you were the one saying unbounded there. If you see negatives in the ratio test with primal or two-phase, then you'll see that. Okay. Dual simplex as well. Goal is the only one where you're like, that means I can't do anything to the goal. Okay. But for anything else, unbounded. That's it. It's unbounded. Let's see. Now, I'm just going to start up one exercise in goal programming, then we'll be done. If you're tired and not listening, I mean, I can't keep you, but it is helpful, I assume. No. You can sleep when you're dead. Saying the one that goes home. Okay, so I'm going to quickly give you a little bit of help with this. But after you see my help, you're going to be like, oh, okay, I'm okay. Okay. So what's different than what you're used to on this exercise? The equals to. Okay. So that's our problem. It's not a problem, but what do you do? Okay? You're going to have a goal for below and above. Same goal though, just split into 2. So when you create your Z, this is now in order of importance, so that's number 1, 2, and 3. So when I create my Z2, I'm going to have a Z2 with a plus and a Z2 with a minus. And I'm going to calculate the same way, but I have to think, what am I minimizing? Now, this depends on how you set it up. I mean, my thinking and your thinking is not always the same. Or I might tell you what I'm expecting, okay? So, min Z2 plus. My logic is saying I'm minimizing the amount above. That's my thinking. You could have gone the opposite. I'm thinking minimizing the amount above. So I'm looking at no, not that one. Which one? Or is it that one? Think about what do you want. I'm minimizing the amount above. So that's something I want to stop from happening, right? If I minimize that, I don't want it to happen. So what should it be then? So it was correct, right? So think about it, I'm minimizing the amount above, so it should be below. So when I check my constraints throughout the pivots and what, I'm looking at it being less than or equals to. For the minus, I minimize the amount short. So what do I want it to be? As much as possible. Then you have your signs to keep on checking to know if that part is met or if that part is met. But they won't both be something. It's either going to be none of them, so equals to 0, 0, so exactly met, or you're going to be below, or you're going to be above. It can't be below and above at the same time. It's the same goal. Okay. Now, the others, you do that whole thing. I want it to be above, so I minimize the amount it's below. I want this one to be below, so I minimize the amount it is above. If I've got penalties, I put the penalties with. Do you get what I'm saying? This penalty is, I want it to be above, so it's going to happen when it's below. I mean, I'm only being penalized if it's not meeting the goal. Do you get that? Add some random penalties to help you think. You get that? This one, it tells you if it's above, you're going to be penalized 2. If it's below, you're going to be penalized 4. So put the correct coefficient with the correct z. Okay. For the last one, less than is what I want. So when am I penalized? When it's more. Right, plus. So that's how I'm going to set it up. Then, just to show you, you have the Excel sheets. Oh, sorry.
With G plus and 4 do those sort.
It depends on how you thought about it now. So let me just write it on the other slide. So we're saying 2 for the plus, right? Oh, why do I write Z? 2 for the plus, the other one is 4. 4 for the minus. So it's saying that you're being penalized for every amount that it's above, it penalizes by 2. So where am I penalizing above? Where am I penalizing the above? Think about it. Here you're saying, I want it to be below, so I minimize the amount above. So the above will get a value of 2. So the plus plus, if you think my way. Okay. For the other one, I want it to be greater than. So I minimize the amount that it is below. Which value is the penalty for below? 4 each, so 4 times that goal being below. Okay. And that's how you're going to set it up. But now the tricky part is, but in the constraints, like what's happening there, it's just going to use the same constraint. Same constraint, because it's the same goal, right? It's exactly the same goal. Let me just show you so that you can visually see it. This one was problem 1. I'm looking for with penalties, sorry. Because the penalties just make sense. Okay, so do you see there Z1, Z2 plus, Z2 minus, Z3? Z2 is the same goal. Do you get that? Different Z's to cover the above. Do you see above? And to cover the below. But when you do your calculation, do you see they're matching with the same constraint? Because it uses the same constraint. You can't use 2 separate constraints because they're changing at the same time. So you have to use the same constraint. Okay. Painful, I know, but that's the worst it can get. Okay. But use the solutions, check it, learn it. But I haven't seen it go that difficult. Usually you'll have less goals or not equals. But in exams, then we tend to be like, now's our chance. Okay, so don't forget about it. Meaning, go through it in terms of expect the worst. So that tomorrow, whatever is thrown at you, you expect it worse. Okay. Yes, Ethan.
I was going to show us how solve it. When he says just because we're trying to figure it out yesterday, we couldn't figure it out.
Do you want to know where I get the values from and stuff?
No, not necessarily. Just want to see how it's set up.
So you'll see we put it in with the penalties in one row because you are kind of comparing them to each other constantly. Then your goals need to have something to know if it's going to be below and something to know if it's going to be above. So all of your constraints going to be equals to. Then you do your whole solver, sum product, min, I'm trying to minimize everything. Now, this would tell me that I've got a penalty of 12 times 3,3333 because that is the amount that it's above, but the penalty is 12. So 12 times that amount plus 15 times that amount will give you a penalty of 90. But what do you do if you don't have penalties? John?
I was just going to ask, so you said that might also say not equals. How would that? You said that might also say not equals. How would that?
They might ask you?
A not equal.
Oh, no. I was saying they might not ask you the equals or but be prepared for the worst. Only then tomorrow you can be like, oh, thank goodness. Okay, but at least be prepared for the worst. Just guys, if you don't have penalties, Solver has no way of differentiating between which goal is more important. I add random penalties to show which goal is more important. If goal 1 is more important, I give it a higher penalty. Goal 1 above though, because that's my focus area. And I give it a higher penalty because then we'll solve that first. These penalties are random because there are no penalties. Okay, meaning you can use Solver to check. yes, it will be in the test in terms of goal programming, but the equals I can't say. But goal programming, yes, it's in the test. Dual simplex, yes, it's in the test. Two-phase, most likely. Can't say yes, but most likely. So be prepared for it because 3 marks would be nice. Graphical solving, most likely. Most definitely, actually, yeah. Let's rather say most definitely, yeah. But you can use, I did say in instructions as well, you can use Desmos, but don't rely on it. Help for the test, yes. Read the instructions just to be sure, okay? Don't just start using it and someone's like, okay? Read the instructions to be sure, then you ask if it's not there. But Desmos is just for helping. Next week, we're building on graphical solutions. I'm not going to show you how to graphically solve again. I'm going to analyze. So if you don't know how to graphically solve or how the constraints work or how the gradient of the line works, it's going to be tough. So please, you can use it for aiding for the test, Desmos, but don't rely on it. You need to get it under your belt before next week. That's why I said before Monday, but sorry for the online guys not seeing me on Monday. All right, Tuesday. Okay, Tuesday for you. In class, Monday for you. Okay. Can I do attendance? Guys online, I'm not going to do your attendance. Like, no, thank you. For online, very good luck with tomorrow's test. Please, high flex is a must. I won't see you, but someone's going to be here. So please, you have to be on high flex. Webcam on, screen sharing, everything. Good luck. I hope it goes well, and I'll see you on Tuesday. Bye, guys online. Have a lovely weekend. Good luck with tomorrow.